Hi guys, the purpose of this screencast is to provide you with one other piece of information to help you with the development of measurement and research scores. Now specifically what I'm doing today is I'm using Excel to look at some real data, and this will demonstrate some of the concepts that we've been talking about when I've been providing you with some information about the vocabulary that you want to use in measurement and research concepts. In addition, this is going to make more sense to you if you do this in conjunction with working on your Excel skill development. Basically, here's what's going to happen. I'm going to provide you with some background information on a PowerPoint. This will take about 4 or 5 minutes, and then I'm going to go and demonstrate some of these concepts by looking at the Excel demo file that you already have your hands on. Specifically in that case, we're going to be looking at the sheets I'm identifying there: reading scores, Eagle Schools, Finney Ford Gray, Douglas Finney Ford Gray. I'm also providing you with a reference to check because a lot of these are going to be looking at the concerns about what happens when we empirically look at Kansas information about the gap between achievement and family income. So I provided a reference there that might be of help to you in that case. When we look at reading scores and the test score, I'm going to look at the format for categories. I'm going to provide you with the demonstration plan to organize data, which is going to, anytime you see data, I think systematically. I want to see a distribution. I want to see what the ranges are. I want to see what the mean and the median are. And I want to see what happens when I apply the standard deviation. That gives me some real clues as to what the data means and how to use it. And then I'm going to provide a little bit of a lead-in to the issue of the relationship income and looking at income-related factors by showing you some organization using the pivot table for this data. Then we're going to go on and look at Eagle Schools. Eagle Schools is so named because this is data that was initially provided in the Wichita Eagle, and they've done this over about a 10-year period of time. This happens to be 2010 data for reading, math, and science scores for about 130 elementary schools in Butler, Sedgwick, and Harvey counties. And we're going to demonstrate the use of the Pearson. The Pearson really is something called, the official name of the Pearson is the Pearson Product Moment Correlation Coefficient. It's a big long term for a concept where you're comparing two variables to look at what the correlation is. We're going to do the same thing by looking at some data for Ford, Finney, and Gray County schools, again public and private. I did this because, as I'm aware and some of you are aware, removing the income factor as a part of state aid is one consideration the Kansas Senate has been looking at this year. So would it have an impact? And that's what I want to show you. And I know that did this purposely because I knew that a lot of you are involved in this process. And these are your schools, you guys in Dodge City and Garden City. And I've done the same thing by looking at Douglas, Ford, Finney, Ford, and Gray is the same thing, only added schools from Douglas County. So why add a big county across the state? Well, very simply, it dramatically increases the number of cases. It increases the diversity of the schools. Because when I look at Ford, Finney, Gray schools alone, the ED average per school is 67.4%. When I add Douglas County in, it drops the ED average by about 10 percentage points. So it's a big dramatic difference. With that, let's go on and let's do some looking here. And I want to go directly to reading schools. And as I said, whenever you look at some data, the first thing you want to look at is look at the categories. And obviously this is a test score file. Again, the categories are across the top of the, and all file, the files F through A are really identification categories. The columns G through M really have to do with performance. So that's how you need to think about this. This is real test data, so it does make sense here what we're looking at. So that means whenever you're looking at your file to make sense out of it, you need to know what these means. Trust me, this is an achievement measure, real data that was done in a school, it's Wichita data, but it was done some time ago, and the identity is clearly changed so that there won't be identification of cases. Let me move on quickly to show you what I'm talking about in terms of organizing the data. And I talked about whenever I see a data file, and I guess I should go back, we're going to do performance, we're going to do total scores in doing this process. Total is nothing more than the sum of these through the average of the other 4 subtest scores. And you could look at this column of numbers. Even if I held your attention on it for a long time, you would see that you could make out a sense by looking at a column of numbers, but when I organize it in a frequency distribution, you can start to make some sense out of it. So you know that we got a low score of 33, we got a high score of 98, so that gives us an idea of the range of scores we're looking at here. So it's a pretty wide range, pretty big number, 3,324 scores. That's a big number. So when we start with the process, the first thing we want to do is look at central tendency. So I used the Excel pivot table to compute an average, and this is what I came out with, 76.5. Now this makes sense because this particular test, I'll add a piece of information I didn't share with you, probably should have, is the fact that at that time the state was using 2-choice tests in reading, so it's kind of like a multiple choice test. The only thing it does is it simply means the bottom half of the scale is inoperable, and it means that these guys that are dramatically below 50 scores, they had a heck of it. They could have done just as well by guessing. So that would give you a little bit of a background information there. Then I simply added some information by subtracting the standard deviation number to create what I call an SD1. And then I did the same thing at the top end to create an SD plus 1. And what that tells me is that outside these are what I might call some outlier scores. Now in this group, like you, I'd probably be most concerned about the guys that are, I'd be looking up these people that had scores down in the 60s and the 50s and the 30s. They're low achievement, so according to this test, so I better start to do some confirming measures. Another thing I do is I added in the median score. Now in this case, the median and the mean are not too far off. They're a little closer than I thought they might be. That means it's fairly close to a symmetrical distribution. So that means that you got about probably, in this case, an equivalent number of real low and real high scores. So it's pretty across the board. Now let's go up one other thing here, and to lead in here, when I was working in the Wichita Public Schools, and I think it's probably the case here, we were aware of the fact, we looked at racial categories, and the first thing that we did when we looked at racial categories is we started to look at the variation of frame-reduced lunch. So for example, we found out that the percent of white students that are on frame-reduced lunch is probably going to be considerably different than the percentage of black students or Hispanic students that would be on frame-reduced lunch. So that was a factor, and that's kind of a lead-in, because sometimes we thought that racial identifying categories was kind of a stand-in for economic information. Now let's move on to the other information quickly, because I want to spend a little time, and we'll first look at Ford, Finney, and Gray. And probably some of you in this group who are looking at this should recognize some of these names. Now the process that was used to come up with these numbers was pretty simple. You can do the same thing yourself. I went to the page on the internet that is the Kansas State Department of Education report card list. And you can simply do KSDE report card and come up with that pretty easily. And for each school, and they're pretty easy to find your school, you're gonna, if you look through the huge amounts of information, you will find percent of students that are ED, economically disadvantaged, on the first page, and then you'll see a subsection for reading scores. And when you go into the total thing, this number is really the additive of three pieces of information here. And if I go down to the right piece of information here, I think oh, here it is right here. No, it's not. Let's go one more here. Yeah, okay, the number here, and this is what I wanted to say right here. Okay, I'm missing the boat on this a little bit. Okay, I guess I don't have that down there, but what I wanted to say was this is a combination of exemplary, exceeds standards, and meets standards. So you got to add some numbers together to come up with this number for reading in 2011, this number for reading in 2012. Sorry about the commotion there, but let's go down and let's see what I come up with when I did that. So, okay, for this group of schools, now this is the average for Kansas in terms of economically disadvantaged students. This is the average for the schools on this list. So you see quite a bit of differentiation. And when I go in here and I do a Pearson, which I'm going to try to do, and let's hope it works out quickly, and I put in the number of arrays. So my first column is B, and that's the ED percentage, and so I put B2 and to B30. That's the schools on my list. And for array 2, I want to put C2, C30. And if I did that right, I think I did. Okay, I've got an, okay. Now my relationship is not as, on that one is a minus 0.33. In other words, that shows there's a relationship, but it's not extremely strong. Now compare that with what I did on Eagle Schools. I did the same thing with Eagle Schools, and for math for 2010, I had a much higher, a much more robust correlation, a 0.60 for math and a 0.77 for reading. Why the difference? Two things. Number one, many more cases, 137 cases in this study. Much smaller number in this study right here, 29 in this case here. Number one, now, and the other factor is there's a lot more diversity of schools in the one that I did for the Central Kansas, the Eagle study. In that study, there are some schools that have very, very small percentages of free and reduced, some schools that have very high percentages of free and reduced. When I looked at the 3 counties in western Kansas, there were a lot of schools that have a high percentage of ED students. You know that. There aren't a lot of schools that don't have very many ED students at all. So that reduces that. Now, when I went to Douglas, I added Douglas to that. Notice I dropped the percent of free, ED students by about 10%, and the relationship, in other words, the strength of the relationship, went from a 0.33 to a 0.39. So there is a relationship there, and that's what you want to look for, and that's kind of a lead into some discussions we'll probably be having later in this course about the relationship of income and achievement. So here are some things you can do with Excel on a practical basis with some data sets, and incidentally, you can go in, use this model. If you're not included in these schools right now, you can set up your own database to do this comparison by simply using KSDE report card data. That's all for now.